In this video, we're going to be looking at what we refer to as the cyclic quadrilateral. Now, these are two things combined. There is the word cyclic and there is the word quadrilateral. So, pause the video and think of what you can call cyclic, what you call quadrilateral, and after which combine your two definitions together and think of what you can say is going to be cyclic quadrilaterals. All right, cyclic means circle, while quadrilaterals means a four-sided plane figure. Hence, cyclic quadrilateral this is when the four vertices of a quadrilateral touches the circumference of the circle. So what we're saying in essence is, if I have a circle and on this circle I have a point from here down here, from here down here, from here down here, from here down here, and I label here as A, B, C, D. A, B, C, D are the vertices of a quadrilateral which is touching a circle. So therefore, you can conclude that this is a cyclic quadrilateral. So a cyclic quadrilateral is when you have the four-sided shape, the vertices of the four-sided shape touching the circumference of the circle. And under the cyclic quadrilaterals, we're going to look at two theorems. And here is the first theorem I want us to look at here. The theorem states that, let's see what the theorem states. The theorem states that opposite angles of a cyclic quadrilateral are supplementary. That is what it says. So opposite angles of a cyclic quadrilateral are supplementary. And what does that mean? I'm going to show you soon now what it means to say the opposite angles of a cyclic quadrilateral are supplementary. So if I have a circle, as we know already, now it is not necessary I need to know the center, and I have this quadrilateral inside the circle, which becomes a cyclic quadrilateral, and I label it as A, B, C, D. This angle A is opposite to angle C. So if I say here is X and here is Y, so the theorem says X plus Y is equal to 180 degrees. Similarly, you will also agree with me that the angle at B is opposite to the angle at D. So if this is M and this is N, then we can say M plus N is also equals to 180 degrees. And this is the concept of cyclic quadrilateral. So opposite angles of a cyclic quadrilateral are supplementary, and this is exactly what you need to know. The second theorem says that what the second theorem tells us is that exterior angle of a cyclic quadrilateral is equal to the interior opposite angle is equal to the interior opposite angle. And what is that? What is the meaning of that? And I'm going to show you something very quickly. So if with a quadrilateral inside a circle, and I extend this line here, so this is still my A, this is still my B, this is still my C, and this is still my D. Now this is the exterior angle. Let's label here as X. The interior to this exterior is this place. This is the interior to this exterior. Where is the angle opposite this particular interior? It is this A. So what it means is that here will automatically be X. So the exterior angle, I repeat, this is the exterior angle. This is the exterior angle here. Now it says the exterior angle of a circle is equal to the interior opposite. So this is the exterior and this is the interior. What is the opposite to that interior? It is this, and that means they are what? They are, it forms that particular theorem. Let us consider another one. Let us assume that we extend here. This becomes another exterior angle. So let's take this exterior as Y. Where is the interior to this exterior? This is it. The angle facing it is where? Is here. And this is also Y. So, and this is the second theorem we would have to consider. So don't forget, the first one says opposite angles of a cyclic quadrilateral are supplementary, while the second one says the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Good. So we're going to take two questions very quickly that would satisfy the two theorems we have just considered, and we'll see what and what we are supposed to do. All right. So I'll take this two questions here. Sorry. Okay. Sorry, please. It's gone. Sorry. So we will take some questions, and I will get back to solve those questions in a jiffy. So I want to take another one on the other theorem on exterior. And now let's go. Now for the first question, this is 97. 97 is opposite x. So that tells us that x plus 97 is equal to 180. X is equals to 180 minus 97, and x is equals to 83 degrees. Y is opposite 76. Don't forget that this is already a cyclic quadrilateral, A, B, C, D, because you have 4 vertices touching the circle. So here we'll have y plus 76 is equal to 180 degrees, and y is equals to 180 minus 76, and y is equals to 104. Now let's look at the second question. The second question here, 50 is opposite x, so that means it will be the sum should give us 180, and x will be what? 180 minus 50, and x is 130. While y is opposite 85, which means y plus 85 is also equals to 180. Y is 180 minus 85, and y is equals to 95. Right. And the third one, Now, I'm going to solve this third one two ways so that you can be able to see how you can use any of the two theorems to still solve anything that has to do with exterior angle in a cyclic quadrilateral. Let's start with the x. Now, let's label first. This is A, this is B, this is C, this is D, and this is E. This x is opposite 85. So, x plus 85 is equals to 180. X is equal to 180 minus 85. X equals to 95. Now, if you don't want to apply the exterior angle theorem, you will just say y plus 95 is equal to 180 and y is equals to 180 minus 95 and y equals to 85. Why did I say y plus 95 equals to 180? Because this forms angles on a straight line. Right? Now let us assume they didn't even tell us to find x at all and we just want to find y. Then we can easily apply our exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So this is the exterior angle y. What is the interior? Here. What is the angle facing the interior? Here. And that becomes another 85 directly. So I hope this video helps you to understand that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle and that the opposite angles of a cyclic quadrilateral are supplementary. You will get so many questions on this theorem that you can actually work with. Thank you very much for watching this video.